Okay, let's take a look at one-to-one functions. First, some terminology. A function has an inverse if and only if no horizontal line crosses the graph of the function more than once or not at all. And a function is one-to-one if each value of y corresponds to exactly one value of x. Therefore, a function f has an inverse if and only if it is one-to-one. All right, so what does all this mean? Okay, a function, in order for it to have an inverse, has to pass a horizontal line test, not a vertical line test. So let's take an example. Let's just say we had a function that looked like this. We'll call this f of x. This would have an inverse because any horizontal line that you draw across this function only crosses the function one time. So this has an inverse. So let's look at another function. Let's say this is a parabola. This is probably f of x is some form of an x squared function. This does not have an inverse because you can draw a horizontal line and it crosses the function more than one time, so no inverse. Now you can make this a one-to-one function if you restrict the domain. So we'll get into some examples about that a little later on. So finding an inverse algebraically, we've already done this, but we'll just do another example. F of x is equal to 7 plus 4x over 3. And we know by looking at it, the domain of this is all real numbers. So let's go ahead and find the inverse. So we're going to say y is equal to 7 plus 4x over 3. Switch x and y. X equals 7 plus 4y over 3. So we're going to multiply by 3. 3x equals 7 plus 4y. Divide or subtract 7. 3x minus 7 equals 4y. Then divide by 4. 3x minus 7 over 4. That's our f inverse of x. And we look at the domain on that. There's no restrictions on the domain on the inverse. And since both of them have all real numbers as their domain, we don't even have to do a horizontal line test or graph it because we know that it does have an inverse. We could also verify by doing f of f inverse of x. That has to equal x, and likewise f inverse of f of x also has to equal x. And so there's another way that you can tell if a function has an inverse. Okay, in this example, we're going to restrict the domain of a function so that it has an inverse. So we're given the function f of x equals x squared minus 4x. And we know this is going to be shaped like a parabola. And so for it to be a one-to-one function, we have to make sure that a horizontal line only crosses the function at one point, which means we're only going to draw the right half of a parabola. So to find out where the vertex is, so we know the vertex is at x equals minus b over 2a. So that value minus b, so it's minus a minus 4, which is 4 over 2a. A is 1, so we're 2. So we know that the x component of the vertex is at x equals 2. So now we just have to find the y component. So we plug in 2 for x. So we have y equals x squared minus 4x at x equals 2. So that's equal to 2 squared is 4 minus 4 times 2 is 8. So that's equal to negative 4. So our vertex is at 2, negative 4. So we can plot that. 2, negative 4. This is our vertex. So this is where we're going to start. graphing with this. So now we need some more points. Okay, so when x is 0, well, x can't be 0 because it can't be less than 2. So when x is 4, go to the original, which is this right here. So when x is 4, we have y equals 4 squared, which is 16, minus 4 times 4, 16. So 4, 0 is a point on the curve. And I'm just going to sketch this. So it's going to, this parabola will start out here, and it's going to go something like this. Okay, now we need to find the inverse. So this is, just put in this point here, 2, negative 4. So we know that the inverse is going to be at negative 4 too, because we're just switching the x and y values. So we know that the inverse is going to be negative 4, 2. 1, 2, 3, 4. So it's going to start right here. And this value here is right here, coordinates 4, 0. So we know the inverse is going to have coordinates of 0, 4. 1, 2, 3, 4. So it's going to be here. And so the inverse is going to be something like this. So this is f inverse of x, and this is f of x. So the domain of f inverse, let me do it in red. Domain of f inverse is going to be domain x is greater than or equal to negative 4. And the domain of the function x greater than or equal to 2. Okay, so one more thing. What if I asked you to find the equation of the inverse? Okay, so let's do that. This will be a fun exercise. So let's write the inverse again. Let's write the function. F of x is equal to x squared minus 4x. And you want to find algebraically f inverse of x. And restrict the function of the inverse and find out what that is algebraically. Okay, so let's start off like we normally do. Y equals x squared minus 4x. And we're going to switch the variables. X equals y squared minus 4y. Well, hard to get y by itself in a case like this, so we have to kind of go back in our algebra and figure out how are we going to do this. Well, one way, probably the easiest way, is let's complete the square. So we have y squared minus 4y. We take half of 4, which is 2. 2 squared is 4, so we're going to add 4. But if we add 4, we have to subtract 4. Okay, so now x equals, the y squared minus 4y plus 4 is a perfect square trinomial. So this is y minus 2, quantity squared, and then we have our negative 4 out here. So we just add 4 to both sides. X plus 4 equals y minus 2, quantity squared. Okay, so we take the square root of both sides. So we have plus and minus square root of x plus 4 is equal to y minus 2. And finally, we add 2 to both sides. 2 plus or minus square root of x plus 4 is equal to y, which is our f inverse of x. However, now this is going to look something like have the shape of that. And so all we want is the top half of this. So the vertex is right here. We want the top half. Easy enough to get. We just don't take plus or minus a square root. It's just going to be 2 plus square root of x plus 4. And that's equal to f inverse of x. Now, we can look at this equation and say, okay, what's the domain? Well, from here we can tell that the domain x has to be greater than or equal to negative 4. And so this is the equation for the inverse, f inverse 2 plus the square root of x plus 4. Okay, that was fun. So we're done with 1.9, but when you're graphing inverses on the same graph as the function, remember that they are going to be a mirror image or reflected on the y equals x axis. So when you're sketching them, make sure that's the case.